Good morning. Now I am going to start the first chapter of chemistry. The first chapter of chemistry is given solids. Regarding solids, you all know. Actually, we know the main three properties of matter are solid, liquid and gas. We got it in class 9, we got it in class 11 also a bit. But now we will have to study in detail. So the chapter is confined within solids. I have given solids. You all know what are solids. The substances which have definite volume and definite shape. The substances which have definite volume and definite shape are called solids. Now, you know regarding solids, they have certain properties. First of all, solids are very rigid. Solids are very rigid. Why solids are very rigid? Solids are rigid because the constituent particles have their fixed positions and they oscillate about their mean position. Solids are always rigid. Why solids are rigid? Because the constituent particles in solids have their fixed position. They cannot change their positions. They can just simply oscillate to and fro motion. They can oscillate about their mean position, and that's why they are very rigid. On the contrary, we can say that in solids, the intermolecular forces is the strongest. In solids, the intermolecular forces is the strongest, and that's why they are very rigid. Here, you give a envy point that out of the three main states of matter, solid is given. Liquids and gases are also there. Liquids and gases are called fluids. Mind it. Liquids and gases are called fluids as they have a tendency to flow. Liquids and gases are called fluids as they have a tendency to flow. So, solids, we need not study regarding liquids and fluids, just given a point that liquids and gases have a tendency to flow, that's why they are called fluids. Now comes second topic, classification of solids. Next point, classification of solids. Solids are classified as number 1, crystalline solids. Now, what are crystalline solids? The substances whose constituent particles. Now, what is constituent particles? The constituent particles may be atoms, ions, or molecules. Constituent particles means atoms, ions, or molecules are arranged in a definite are arranged in a definite geometry. Better we can say arranged in definite geometry pattern, geometric pattern, in a definite geometric pattern, are arranged in a definite geometric pattern in three-dimensional space. In three-dimensional space are called crystalline solids. Are called crystalline solids. That means crystalline solids, the substances whose constituent particles, the constituent particles may be atoms, ions or molecules, are arranged in definite geometric pattern in three-dimensional space are called crystalline solids. Number 2, you have written this one. Number 2, amorphous solids. Number 2 is amorphous. Amorphous solids, those substances whose constituent particles are not arranged in a definite geometric pattern in three-dimensional space are called amorphous solids. Write it. So we have classified solids in two types. One is crystalline solids and the other one is amorphous solids. Crystalline solids have definite geometric pattern, but amorphous solids do not have definite geometric pattern. But now we will have a detailed study regarding crystalline solids and amorphous solids. What are their differences? So next heading is differences between crystalline and amorphous solids. You give the heading differences between crystalline and amorphous solids. Differences between crystalline and amorphous solids. You give heading 1 crystalline solids and then amorphous solids. Crystalline solids, amorphous solids. Number 1. From definition, we have that first one, that crystalline solid they have definite regular geometry. And here the number 1 point I will come, they do not have regular geometry. Number 2, they have sharp melting point. Okay. Number 2, they melt over a range of temperature. That means they do not melt at a particular point or particular temperature. That may be a bit less, that may be a bit more. So over a range of temperature they melt. Number 3, they have definite heat of fusion. Number 3, they do not have definite heat of fusion. Number 4, they are anisotropic. They are anisotropic in nature. Number 4, they are isotropic in nature. Number 5, they true solids. They are true solids. Number 5, they are pseudo means false. They are pseudo solids or supercooled liquids. Clear? Have you written? Okay. Now, out of these differences, I think you need clarification of one term, that is anisotropic and isotropic. What is meant by anisotropic or isotropic? That will be our last point of discussion for today's class. Now you give heading anisotropic. Anisotropic. It means physical properties are different in different directions. Anisotropic means physical properties are different in different directions. Isotropic means it means physical properties are same in all directions. So, what have you understood? For crystalline solids, their physical properties are different in different directions, and that's why they are called anisotropic. On the contrary, for amorphous solids, their physical properties are same in all directions, and that's why they are called isotropic. Hope you have understood the topics. This is for today's class. Tomorrow we will have our second class. Thank you. Good day.